Okay, we have yet to another integral from the MIT integration being 1991, problem 14. We have the integral of secant cubed x dx. Okay, this is kind of an important but routine integral that you learn like in your first integration class. It's a good use of integration by parts, so let's just go through that using the DI method. So for the DI method or tabular integration, we'll set up two columns, one to differentiate, one to integrate. Now we just have one function, so what I want to do is split this so that we can use this. Now, I mean, we could create a 1, but that's not really going to help us too much here, I don't think. And so secant cubed, I can split this as secant x times secant squared x. So I want to pick which of these I want to differentiate and which I want to integrate. Well, secant squared x is easy to integrate. So of course you could choose this the opposite way, but this works out pretty nice the way we have this set here. So if we integrate secant squared x, we're just going to get tangent x. Derivative of secant x is going to be secant x tan x. So then we'll have part of our solution on the diagonal. So let's just write that part down. We'll have secant x tan x. And then here, I'll bring the minus up front, and we're going to have tan times tan. This is going to be tan squared x secant x dx. Sorry, kind of ran out of room. Now for tan squared x, I want to use the identity on this. This is the same thing as secant squared x minus 1. So what I'm going to do is let's copy down this first part and keep that going. So I have secant x tan x. And then what I'm going to do is I want to distribute, we have this secant x, I want to distribute this in here. So when I do that, we can split it into two integrals. So like for the first one, we're going to have minus the integral of secant cubed x. Then here minus secant x times minus in front, this just gives me plus integral of secant x. But the thing to notice now is this here, this is the same as our original integral that I'm just going to label I. So this thing is I. Okay, so we'll put our I on the left side, which is what we started with. So then if I just add an I, if I add this on both sides here, now we have two copies, 2I, and we're going to have secant x tan x plus, now this is a very common integral. The integral of secant x is going to be just natural log absolute value secant x plus tan x. But all we need to do now is just deal with the fact that we've got two copies. So I can divide by 2 here to isolate our integral, divide by 2 here, add a plus c, and that's it. Okay, so as you can see, not too bad, but also this is a good one to remember as a formula so you don't have to do it out every single time you come across this. There you have it, MIT 1991, problem 14. Thanks everyone for watching. Have a good day.